I'm Lee Tushler from Design World Magazine, and I'm here with Don Dapkus from TI. Don's going to talk to us a little bit about digital audio. Don, the cool thing about audio amplifiers these days is when you want it, used to be that when you wanted a lot of power out of an audio amplifier, you got something that was like this.
Yes.
Now it's like this and it's digital.
Exactly.
Tell us how you managed to do that with something that looks like a switching power supply without adding a bunch of distortion and really terrible audio effects to it.
Okay, so at TI we specialize in Class D amplifiers, and what those are is they are a special modulation technique that we use that gives you very high audio quality and very high audio efficiency as well. So we can pack a lot of power into a very small space. So for example, I have one of our customer systems here which has 400 watts in this small box. So as you mentioned, Lee, in the previous generation of Class AB amplifiers, you would have to have a giant heatsink in order to dissipate all the heat that the amplifier was generating.
The heatsink would be bigger than that.
Exactly.
So how do you manage to do that?
We can take either an analog audio input signal or we can take a digital audio input signal, and we convert those from the incoming format into a PWM output. So as you mentioned, it's very much like a switch mode power supply where we now PWM the output of the amplifier, which allows us to get very high efficiency. The previous generation products were all Class AB, and they had a continuous output which resulted in high current and high voltage at the same time. So when you multiply current times voltage, you get a lot of power dissipation. With our PWM output, we're either all the way on or all the way off. So we never have a condition where we have high voltage and high current at the same time.
How do you reconstruct an audio wave from that without getting something that's got a lot of fuzz in it?
The PWM frequency is 250 kilohertz and above. That allows us to very accurately reproduce the audio signal. And in order to run it to the speaker, then we run it through a low-pass filter. So example, in the customer system here, they have inductors and capacitors on the board that makes a low-pass filter with a cutoff frequency of about 30 kilohertz. And that knocks that square wave back into whatever the audio signal needs to look like. And it's primarily used for EMC issues, because as you can imagine, a PWM at 250 kilohertz with fast rise and fall times would generate some EMI issues. So the LC filter is used to minimize that. It's especially needed in an application like this, which is for an automotive application where you have long speaker wires going to the speakers, and car manufacturers are very concerned about EMC, so they need to have very low emissions outside of the box. So they put all the stuff that's generating EMC inside the box and they filter it before it goes out to the speakers.
So that's very high efficiency. What type of efficiencies are we talking about compared to an AB amplifier?
So an AB amplifier can run the theoretical maximum is in the low 70% for it. Typically they run much lower than that, maybe 30 or 40%. And our Class D amplifiers run at around 90% efficiency.
Interesting. You've also got a demo here behind us.
I do.
Can you take us through that?
Sure. This is, these are some head units. So the one on the left is the original one, which has a Class AB amplifier inside of it. And then the one on the right, we actually retrofitted it to use one of our new devices, the TAS 5404. And we made this module so they can basically plug in where the Class AB amp is normally in the system. Then what I'm doing is I'm playing a MP3 file, which is a sine wave, to generate some power to the loads up here. And what happens is then we are measuring the temperature of the heatsink back here. So you can see, again, for a Class AB, it's got a pretty big heatsink here. And for the same conditions and everything, the Class AB system's heatsink is running at about 51 degrees C, and the Class D one is only running at 36 degrees C. So it's running quite a bit cooler. So what that means in a real-world application is the customer may not need to add a fan, or they could use a smaller heatsink to save space and weight in the car for better efficiency that way as well.
And it saves them quite a bit of weight, too.
That's right, yes.
Yeah, which is also important.
And aluminum is not cheap these days, right?
Yeah, exactly. Great, Don. Well, that's interesting technology. Thank you very much.
All right, you're very welcome.